Thank you for joining us today. For all in this room, it's probably clear what BudCut is, but for all the external people, so BudCut is a Horizon project started in 2024. So we have already 30 months behind us and round about 1 year in front of us. We will show you today some progress. We will start with a public demonstration, and afterwards we will talk about the MVP status.
So our address is badcat.list.lu. And if you don't have any account, you have to register. This is the information about your name, some password again, and you will confirm it, and your country and the city. And now you can log in. I have already account that I did some workflows and simulations, so I will use this one. Now we can go to the battery configuration part or the workflow orchestrator. Which one you want to use. This is the welcoming page. And you can, when you go to dashboard, you will see there's an overview of your previous workflows. You will see the overview of your recent simulations, the workflows in there. So how much did you complete? Or if they're still running, it's still running. Or if there's any failure, you will also see in this overview part. And you can also do quick actions like the new configuration or the view charts as you wish. But we will go with the order. So this top menu is like the main menu, and on the left side, you will see the subcategories of the menu. So when you go to configurator, you can create new one in here. And we can also create new battery configuration with you if you wish. So type a name like lib Pyrex. And then the chemistry type is the lithium. So the temperature in the Kelvin, we can do like 33, maybe. Too high or too low? Okay. Let's just write some random values. And then the cathode porosity, it's also again like 0 and 1 between. So I think it's fine, maybe. And the thicknesses, we can stay it as it is. And we can save our configuration like this. And we can also export it. So this is our JSON file, it will be shown in here. You can view the check if it's correct or not. And if you think it's not correct, so you can edit. Let's say we did this Brex one, so we want to change something. From the edit part, we can change. Let's say this is too thin. Let's do it like 45, this one. And then we can save it in here. So we did 45. Yeah, this one. Okay. So we can also change it from here. And let's say you want to delete something. Just click on delete and type delete. So it will delete. But again, if you want to add, you can edit. So we don't have any EV model now. We deleted it. And now we can start to create our workflows. So this is the main one that I show you in our meetings, and I think we are all kind of familiar with the steps. So this is the LibNib manufacturing workflow, lithium batteries. So first step, we have the mixing. And then the second one, it's coating, drying, calendaring, cutting, assembling, filling. And then this is our part actually we are working on mostly. This is the forming step, which we have the integrated to surrogate model. It has the input as a current and voltage. And then as a prediction, it predicts the SEI rate and the temperature. And then we have the decision tables with integrated with the ASP, answer set programming. And based on the ASP decisions and the MN decisions, it will say, okay, it is accepted by me, by ASP layers, so you can move on, you can go to next step. If it's not, it will stop in here, and you will see an error on the link ahead. It will it's not saved, it's not proceeded like this. This is the common platform that we use to create the workflows. So it's the same interface, we can say. We have it in here. And on the right side, you have the definitions of your workflow of your tasks. If you want to see more, there is an XML in here, which has lots of XML coding. So this is the background of the BPMN files in more or less. And let's start one lib manufacturing. So I prefer to add some dates so we can trace of our workflows, what happened. So this is the 1st of July. Let's add also workflow as a name. You can also see the XML file, and on Camunda part, you can see the diagram itself, not the XML file just. So, and now I'm deploying it. It's saved. It's successful deployed my system. Now it's time that I can use this battery and the workflow together. So this is the one that I choose. I created, sorry. And you can also see the details of the parameters you have. And then you can select the workflow you have created. So I have created other workflows before. I can also see them, but this is the one that I just created, this one. So this is the summary of the workflow you have created. You can check again before you start any new process. And I click on the start workflow. It started now. Now it will direct me to the running instances part, and this is running currently. And it has some metadata about the workflow, some information. It's the status, who created it, which config it uses, and when it started. So like I said, so far, we don't have any data in the mixing, coating, or the drying parts. We are currently investigating the forming step mostly. So they will just pass to another task. And if it's green, it's completed, like you can see in here. If it's blue, it's active. It's currently running. So this will just take 10 seconds for each task. But in the forming step, when I calculated it, it's like 2 to 3 minutes. It can change. And in the forming step, the surrogate model takes the last 30 time step of the data, which we get it from the link ahead system. And then it's produces the predictions. It gives us a 2 output. Also, you can see the logs in here when it started. As you can see, it started and it's completed immediately. So it's fast. And after the forming step, everything will move so fast because the ASP layer just does the security layer, and it will just check and it will say yes or no. The most time we will spend on the workflow is the surrogate model, and it's only maximum like 2 or 3 minutes. And when you want to see the battery inputs, like the data that we have, these are the voltage and the current value we take. And as a SCI rate, it produces like 0.0039. And the temperature is like 298.18. And since it's in our threshold, ASP will say, okay, it's safe. Now you can move to the next step, which is the gazing. This is the input table. You can also check, trace it. So now we can do the MCO part. Johan, you can, yes. No, we integrate with the Python workers that we created in the code. We send some requests to the Camunda API, and then with the Python, we communicate and we do our job in there. So also in this forming task, I say, okay, now it's my time to get the data from link ahead. I take the data, I process the data. There's the surrogate model in there. So I also call the surrogate model. Okay, now it's your time. You can do prediction. And when the prediction is done, I'm saying to Camunda, okay, it's done. So you can move to the next step if it's okay, if you allow it based on the decision. Okay, and now we have the MCO part, MCO workflow we have. So in here, it will take the PyBAM simulation study, which Johan will explain.
Sorry, just as a question, it was not super clear. If I have if I have some workflow or something that I want to implement, is there Do I have to do it through the GUI, or there is other ways?
You can import your BPMN, but
Okay, BPMN.
at the background, I also need to write the code. Like I need to know what will going to happen in this task.
Okay.
Okay, this is the MCO part. So we basically created 3 tasks, which is first one is the PyBAM simulation study. It will import the PyBAM library. And then we have the next step is the DSS, which is the Pareto browser. You can interactively visualize it. And then at the last step, we have the decision task, which will be done by the user. So based on the Pareto answer, we can say a human will choose the optimal case, like optimal parameters for the case, for its case. So we added the MCO in here, and I think in Teams.
So I guess we have a little bit of latency for our visualization due to Teams, but it will come in a minute. Okay, so now, what do we see here? So this is the decision support tool for your battery production. So you want to know what's the best way of producing my battery, what's the best formation protocol, and you get this answer from this tool. So what does best mean? So we optimize something, and we have some objectives, right? So we have to define that, and you as a user can, in principle, freely decide that. So at the moment, we have fixed 5 objectives with respect to which we want to optimize the battery formation, and those 5 objectives are the ones that you see here. So the first objective is we want to maximize the initial capacity of the formed battery. So initially, before you let it undergo the aging process, that's what's meant by initial. So when it comes out, right after it comes out of the formation process, what's my discharge capacity? And this should be as high as possible, and that's why we want to maximize that. With respect to our formation protocol parameters, which are the formation charge rate, the formation discharge rate, the upper cutoff voltage in the formation process, the lower cutoff voltage in the formation process, the rest time, and the number of formation cycles. So we've got 6 optimization parameters with which we can play, and we want to find the optimal formation parameters with respect first to the initial capacity or discharge capacity, to be more precise. And then we have 5 other objectives, namely we want to, in addition, minimize the discharge capacity loss. So we compare the discharge capacity at the beginning of the aging process, which was our first objective, with the discharge capacity at the end of the aging process, and we want to minimize the distance. So the degradation should be as small as possible. And then we have some other degradation indicator quantities, namely the SEI-related capacity loss. This is this one. We also want to minimize that, of course. The lithium plating related capacity loss. And finally, we have resistance related degradation. Okay. So we explored our input parameter space, ran PyBAM simulations to see what PyBAM predicts. And then, okay, what do you see? You see blue points and green points. What does that mean? So all the points, the blue points visualize all simulation results. The green points are the ones that are Pareto optimal with respect to the 5 objectives that we set. And you want to pick one of those. And okay, so maybe you don't want to just arbitrarily pick one. So you need a little bit more assistance in which one is best in my current situation. And in order to assist you in this decision, we have these sliders here. So for each objective, you have a slider, and you can, with this slider, restrict what you allow. Right? You might want to say you might want to accept initial capacities only if they lie a bit, yeah, if they lie above this value here. So you might not want to accept any initial capacity like the lowest one that you can see on the left, but you want to, yeah, it might be advisable to restrict it to the initial capacity to lie a bit more above. Okay, and then you can do that, and this filters out those points that violate the restriction that you just set. And you see those filtered out points here now. So they are grayed out. And so we already substantially narrowed down the set of acceptable optimal points. And now, okay, let's explore it a bit further visually. So maybe the SEI degradation value that you can see here, so it's above 1. So you want to filter out that as well. And you finally decide for this point. Let's say we want this point now. So here you can see, this is the performance indicators that this point represents. But now you, of course, want to know, how do I achieve that, right? I mean, this information doesn't tell you at all how I achieve that. What's the formation protocol that lies behind that and that realizes that? And in order to see that, we have to switch the laptop, because we, there is one thing that we forgot when transferring this UI into the Camunda UI, and this thing is the interaction that I'm going to show you now. And for that, I have to quickly share my screen. Hold on. Seems like something is... It seems I'm out of the meeting. That's most unfortunate. Let's see. Okay, it seems okay. Maybe it works. So I was kicked out of the Teams meeting. So I try it once. If it doesn't work, I'm just going to explain what you see when you double click on your decision. So I think it's not gonna work. Okay, sorry for that, but we know the reason. There's just one the code that the code that implements the interaction that I'm gonna describe now is just was forgotten to transfer. We forgot to transfer it. Okay, so you double click on this point because you decided you want to have that now, okay? And then an extra window is going to pop up, which shows you just the formation protocol parameters that underlie this point, okay? And then you've got, you've got an extra button which allows you to just export those formation protocol parameters to a CSV, and then you can send that to the operator, and the operator can then put it into the ASP to make a final check whether or not this operating point is safe or not. And for that, I hand over to Buse again.
So yes, like Johan said, the next step will be the integrating in our workflows. For example, in here, we will add after the surrogate model prediction to MCO part, and then it will show us the Pareto front, which will give the best optimal cases, and then the human will decide which parameters will to choose, and then after it choose, it will do the ASP will comes in this section, so it been like this, and the ASP will be again the final layer. That's our next implementation we are thinking. And after the workflow, so this is the whole list that you can see, these created ones. And after the workflow, you can do simulations, which are from the PyBAM simulations mostly. Again, we have the two different chemistry, but the battery types, lithium and the redox flow. So if you choose lithium, you can see SPM, SPME, DFN. It will have more curves. It will show the voltage versus over time to us. And you can also do with the DFN and other stuff in there. And you can see the information, which it's a time series, it's a spectral, or it's a tabular data set. You can also see in here. And the models we have, this is more likely the physics-based models that it's like DFN P2D, SPME, LFP, and so you can also see the data set models in here. And this is the chemistry inside of the battery, the chemistry-based library you can see. The sodium ion you have, the vanadium redox flow you have, or the LTO and other types of the chemistry library that you can also see in here. And then we have the performance that's based on your timeline of how much you succeed, how much you didn't succeed, or some kind of summary of your performances, like average runtime, success rate, average CPU usage, or how much you wait, and so in here. And if you want to play a little bit more with the C rate or temperature or capacity you have, you can also use this one. It will show you some plots again. And then the material you have during each task to creating the batteries, you will see the materials in here and the type of the role of the battery, the formula maybe, and then the density, other type of behaviors or the attributes you want to see from in the production line. So we have this workflow, and this is the format that we want to convert. So we have 4 types: DPP JSON-LD, DPP Turtle TTL, Catena X, or Data Space JSON-LD. All information you might need in the DPP. Yes, Tawakol Sadrabadi.
I'm Mohammed from University of Warwick WMG. There's this capability of drag and drop processes, and they get together. Yeah, like this. For example, you have mix and coating, drawing, and so on. So can you just dynamically choose which ones you want to connect together, or it's just no, that you have to run the whole workflow?
Okay, but I didn't exactly understand, I must say.
Thank you for the question. Actually, the main added value of this that you have actually that you can repeat actions, which means actually we have a number of workflow that you can store within the system and they can call anytime. Then they have 2 options. Either you go actually to the database of the platform and you select a specific workflow you would like to run. That's a repeatable workflow. You also create your own completely new workflow from it. And you have the 2 possibilities actually.
Okay. So you can create your new workflows.
Actually,
based on the existing models.
You have 2 options to create your workflow because it's no code. If you are just familiar with BPMN, you have just to create your tasks there, and you should know essentially what is behind the task. This is actually most of the time the tricky part of it. It's not the creation of the task by itself, and then you can run it. We are showing this because this gives an overview essentially how the battery system, manufacturing system is there. But any task actually could be duplicated actually in other, sub workflows. To answer your question actually in 2 words, yes, you can create your own workflow. Then you can also use the stored workflow within the platform.
Okay, thank you very much. Thank you.
Thank you.